So now we're going to look into adding and subtracting fractions. So first, when we are adding and subtracting fractions, we find the lowest common multiple of the denominators. Then we scale each fraction so they both have the lowest common multiple as the denominators. And then we add or subtract the numerators, and we do not change the denominators at all. So let's look at this question here. A jug contains 7/8 liters of lemonade and is left in the jug after 1/6 liter is poured out. Okay, so essentially for this question here, we are going to be doing subtraction. So we've got 7/8, so it contains 7/8 of a litre of lemonade, and 1 litre of the lemonade is being poured out, and we need to work out how much is left. So we're going to do 7/8 minus 1/6. When we subtract or add fractions, we need to make sure that the denominators are the same. The denominators here are not the same, so we need to work out the lowest common multiple of 6 and 8, which is going to be 24. Because 24 is in the 6 times tables and 24 is also in the 8 times tables. So we need to convert these two fractions into over 24. So to get from 8 to 24, we have to times by 3. So we do the same thing to the top. Whether you do to the bottom, you do to the top. So if we times the bottom by 3, we have to times the top by 3, which we get as 21. To get from 6 to 24, we have to times by 4. Whether we do to the bottom, we do to the top, so we have to times the top by 4 as well to get 4 over 24. Now that the denominators are the same, which is 24, all we need to do is to subtract the numerators. So we do 21 subtract 4, which is 17. So our answer is 17 over 24 litre of lemonade is left. In the jug. Another one here, 2 pipes of length 2 3/4 meters and 1 2/3 meters are joined end to end. Okay, these two are important. How long is a new piece of pipe? Give your answer as a mixed number. So for this question here, we are going to be doing addition, not subtraction. So 2 3/4 add 1 2/3. So what we do here, these two are in mixed numbers, so we have to convert them into improper fractions. So to convert to improper fractions, what we do is we do the denominator times by the big number here, so 4 times by 2, which is 8, and then we add 3, which is 11. So the 11 will go to the top, so it'll be 11 over 4. Same thing with this one, so 1 2/3, we do the denominator times by the big number, so 3 times by 1, which is 3. Then we add 2 to get 5. Okay, so 11 over 4 plus 5 over 3. Now, as both of the denominators here are different, we have to find the lowest common multiple of both of them, which is going to be 12. as 12 is in the 4 and 3 times tables. So to get from 4 to 12, we have to times by 3. So we times the numerator by 3 as well. 11 times 3 is 33. To get from 3 to 12, we times by 4, so we have to do 5 times by 4, which is 20. As the denominators are the same, we just need to add the numerator together, which we get as 53 over 12. So, to convert from an improper fraction to a mixed number, which the question is asking for us to do, we need to work out how many whole 12s go into 53. So we have to go our 12 times tables, which is 4. 4 times 12 is 48. 53 subtract 48 is 5, so that's our remainder, so our 5 is going to go up there. So our answer is 4 and 5/12 meters. Okay. When we multiply fractions, we multiply the numerators and multiply the denominators together. Sometimes we may cancel down before multiplying the numerators and multiplying the denominators. So let's look at this one here. We've got 8/15 times by 5/12. So what we could do is essentially do 15 times by 12 and 8 times by 5. But what we can do before we do that is cancel down. So when we cancel down, we look at the numbers that are diagonally across from each other. So essentially the 12 and the 8, which are diagonally across of each other, that's one group. And then the 15 and the 5 is another group. And we see whether we can cancel them out. So let's look at the 15 and 5. 15 and 5 are both divisible by 5. So 5 divided by 5 is 1, and 15 divided by 5 is 3. 8 and 12, they are both divisible by 4. So 8 divided by 4 is 2, and 12 divided by 4 is 3. So now we just need to do 2 times 1, which is 2, and 3 times 3, which is 9. Is that simplified? Yes, it is. And that's it. Okay, so let's look at this one. So first of all, we need to turn this mixed number into an improper fraction. So to do that, we do 2 times by 9, which is 18. And then we do 18 plus 7, which is 25. So 25 over 9 times by 3 over 10. And then what we can do is cross cancel out. So 25 and 10, they are both divisible by 5. And then the 3 and 9 are both divisible by 3. So we do 5 times by 1, which is 5, and 3 times by 2, which is 6. And that is it. So now we're going to look at dividing fractions. When we divide fractions, we use the KFC method, which stands for keep, flip, change. So we keep the first fraction the same, flip the second fraction, and then change the sign from division to multiplication. So let's put that into practice. So we have 3/8 divide by 7/10. So if we use our keep, flip, change, we keep the first fraction the same, so 3/8 stay the same. We flip the second fraction, essentially that means the 7 will go down here and then the 10 will go up there. So we get 10/7. And then we see, which is for change, so we change from division to multiplication. So we do 3 times 10, which is 30. And then 8 times 7, which is 56. We can simplify this as both of them are divisible by 2. 30 divided by 2 is 15, and 56 divided by 2 is 28, like so. Let's look at this one here. So we've got two mixed numbers, so as always we have to convert the mixed numbers into improper fractions. So let's look at 2 and 2/5. 2 times by 5 is 10, add 2 is 12. 5 3/4. 5 times 4 is 20, add 3 is 23. Okay. Keep, flip, change, keep the first fraction the same. Flip the second fraction, and then change the sign from division to multiplication. So we do 4 times 12, which is 48, and 5 times by 23, which is 115. Now we're going to look at fractions, decimals, and percentages. So this table here shows you a list of tables that, well, list of fractions, decimals, and percentages that you should know off the top of your head. So a half is 0.5, 50, which is 50%, a quarter is 0.25, which is 25%, an eighth is 0.125, which is 12.5%, a third is 0.3 recurring, which is 33.3 recurring percent, a fifth is 0.2, which is 20%, and a tenth is 0.1, which is 10%. These are the stuff that you just need to know off the bat from the top of your head. Now we're going to look at converting. So when we want to convert from a fraction to a decimal, we divide the numerator by the denominator. So for instance, we can say 32/100. So when we want to convert from a fraction to a decimal, we are essentially doing 32 divide by 100. And whenever we divide by 100, if we remember, so 30 is the same thing as 32.0. When we divide by a multiple of 10, we move the decimal place to the left. So because there are 2 zeros, we move the decimal place 2 times to the left, like so. So we get an answer of 0.32. Then when we want to convert from a decimal to a percentage, we times by 100. So we do our 0.32 times by 100. When we times by a multiple of 10, we move the decimal place to the right. So because there's 2 zeros, we move it 2 times to the right. So we get 32%. And then from a percentage to a fraction, we divide by 100. So 32%. over 100. Remember, in a fraction, that line means divide. Okay, this question here, write the fraction 5 over 16 as a percentage. So to convert from a fraction to a percentage, let's convert from a fraction to a decimal first. So when we convert a fraction to a decimal, we divide the numerator by the denominator. So if we do our bus stop method, 16 is on the outside, we have 5. I'm going to put 0.0000. So we can't do 5 divided by 16, so put a 0, put our decimal place, and we carry that 5 along. How many 16s go into 50 is 3, and that remains 2, because 3 times 16 is 48. 50 subtract 48 is 2, so that's where we get our 2 from. How many 16s go into 20 is 1, and that remains 4. How many 16s go into 40, and that is 2. 2 times 16 is 32, and that remains 8. How many 16s go into 80? Oh, that one is 5. So we get an answer of 0.3125. Then when we want to convert from a decimal to a percentage, we times by 100. So when we want to times by 100, we are moving the decimal place 2 times because we've got 2 zeros. So 1 and then 2. So our decimal place is here. So we get an answer of 31.25%. To know whether a fraction is a recurring or terminating decimal, so recurring is like that 1/3 where you have that dot above the 3. That's a recurring. But a terminating decimal is like 0.5 when it's not continuous, like it's no continuous number. You've just got 0.5, which is a half. So to know whether a fraction is a recurring or terminating decimal, we simplify the fraction fully and find the prime factors of the denominators. Prime numbers are numbers that are only divisible by itself and 1, such as 2, such as 5, such as 3. And if there are any prime factors other than 2 or 5, then the decimal will be recurring. So let's put that into practice. So we've got show that the fraction 21 over 98 is a recurring decimal. So 21 over 98. First thing we need to do is to simplify fully. Both 21 and 98 are both divisible by 7. So if we divide 21 by 7 and 98 by 7, the top we get as 3 and on the bottom we get as 14. Then what we do is we find the prime factors of 14. So prime factors of 14 is 7 and 2. And because we have another prime factor other than 2, which is 7, that tells us that 3 over 14 is going to be a recurring decimal. So as we have prime factor of 7, this is a recurring decimal. And just to prove my point, if we put 3/14 in our calculators and we turn it into a decimal, yep, we do get a recurring decimal.